Welcome to all. I am Nagarajan, Assistant Professor of Physics, Government First Aid College, Kolar. This is about Bangalore North University, third semester, BSc Physics. Paper, Electricity and Magnetism. This is a learning objective of this session. So here, one can understand the concept of Biots Savarts law and its derivation. So after completion of this session, you can clearly follow the concept of Biots Savarts law and how this Biots Savarts law relates the currents as sources of the magnetic fields. So this is Biots Savarts law. To understand or to study the Biots Savarts law, we have to consider a conductor. This is a conductor I have chosen. In that conductor, we have to consider a small length dl carrying current I. So let P be a point which is at a distance r from the midpoint of dl. This theta, which make theta with the angle made by the current element dl with the point P. Then according to Biots Savarts law, magnitude of magnetic field dB at the point P due to the current element dl is directly proportional to the current I, directly proportional to length of the current element dl, directly proportional to sine of the angle made by the current element with the line joining the midpoint of dl and the point P, and inversely proportional to square of the distance between the point P and the midpoint of current element. So if you combine all these statements, then if you write dB is proportional to ideal sine theta divided by r square, or if I remove this proportionality constant, we will get dB is equal to mu naught by 4 pi ideal sine theta divided by r square. In the vector form, this can be written as dB vector is equal to mu naught by 4 pi I into dl vector cross r cap divided by r square, where r cap is the unit vector and it is given as unit vector r cap is equal to vector r divided by r. So if I substitute this definition here, so then dB vector is equal to mu naught by 4 pi I into dl vector cross r vector divided by r cube. So this is a Biots Savarts law and it holds good only for steady currents. The direction of magnetic field dB is perpendicular to the plane containing dl vector and r vector. So to derive the Biots Savarts law, we have to consider a small element dl of a wire of cross-sectional area A carrying current I. So let n is the number of charge carriers per unit volume. Then each of charge E moving with a velocity v. Then we know I is equal to NEA into V and I is equal to dq by dt. So then dq by dt is equal to NEA into V, or dq is equal to NEA V into d. This quantity V into dt is nothing but dl. Therefore dq is equal to NEA dl. Then the magnetic field at point P due to the current element at a distance r is dB vector is equal to mu naught by 4 pi dq by r cube into vector v cross r, or this dq we know, this dq is NEA into dl. So if you substitute here, so dB vector is equal to mu naught by 4 pi NEA dl divided by r cube into vector v cross r vector. So then this NEA into dV is high. Na into dv is high. Therefore, this reduced to db vector is equal to mu naught by 4 pi I divided by r cube into dl vector cross r vector. So this is known as Biots Savarts law. So finally, the conclusion is, so here one can easily follow the concept of Biots Savarts law and its derivation and the calculation of the magnetic field for the current element. And these are the references we can use. Thank you.